Hey, welcome to part 2 of the Naval Battle multiplayer game build. In part 1 we created the UI for the game in Unity, and now we're going to take a look at the server. On the server side, we're going to use Colyseus, which is an open source multiplayer gaming framework, and we're going to use that in conjunction with NodeJS, and I'll be doing all my editing in Visual Studio Code, which has great support for TypeScript, the language we'll be working in, and you can run everything in the terminal while you're in there as well. It's good. So to start, we're going to use the example project from the Colyseus repository. So let's clone that, and then we'll kind of clean out everything we don't need, and we'll go from there. So I'd encourage anyone who's looking into doing a project using Colyseus to take a look at the documentation, obviously. And these getting started guides are really great. These were how I learned how to use the system, and they're fairly comprehensive. You can see the getting started section for the server here at the top, and what we want is this Git repository. So let's go here. So I'm going to make this terminal window a bit bigger and clone it. Next, we're going to run npm install, and that will give us all of the dependencies. And once it finishes, we can do a quick sanity check. We can run npm start, and we should see the sample project start up and start listening. So when you see this message, listening on 2567, that means the server is ready for players to join. So I'm going to go ahead and stop it because we don't want it to run in its sample mode. Let's clear all that out and make that a bit smaller. Let's open the folder we just created. Let's rename this to Naval Battle. Okay, so the basic project starts with everything you need to get it running, but it's set up for a couple of different samples, and we don't really want to have those running. It's just going to clutter things up. I'm just going to go in here, and I'm going to remove all of the files related to that. So I'm just going to highlight those and just delete them. Yeah, don't ask me that. Okay, and then everything starts in this index TypeScript file. Now that we deleted those files, it's not happy, so let's go ahead and remove those imports. And we'll remove this. And in fact, let's remove most of this. We can remove this, and this, and that. We don't need any static assets, so we can get rid of that as well. We'll keep the monitor, shutdown message, and listen. And we don't need that. Not for a simple project, at least. And we can get rid of that. So basically, we have a server that does nothing now, but that's what we want before we start. Whenever I start a new project and I haven't used this framework before, I like to strip it all the way down to the very basics so that I know what everything is doing. I don't want to ever have code in here that I don't understand what its purpose is. So as we add back everything, we'll be looking at what it's for, and that way hopefully you'll have a good understanding as well. So now when this starts up, we're going to assign the port number and set up a little express server. This is just kind of a little mini web server. And then we'll create a game server using this create server function given to us by the HTTP library. We'll add this monitor on. This lets you kind of like keep an eye on what's happening on the server. We don't need this for this demo, but it's not hurting anything. And then we'll start listening and print out a message, of course, so we know it's working. So how about we see if we broke it or not. Okay, so let's get our terminal window back and issue the start command. Here we go. We now have a server running that does nothing. Now we're ready to start adding in our own code. If you do decide to use Visual Studio, you can run your code and attach the debugger to make troubleshooting easier by configuring a run setting or a run configuration. So if you click this little gear here, you can see some basic settings here. And basically you want to change those for TypeScript and Node projects. Let's just call this debug server. And instead of just saying that the program we want to run is the index, we want it to incorporate TypeScript into this. So let's go ahead and change the arguments a bit. And then we need another parameter here called runtime args. This step isn't necessary, but if you're going to be working on a project for a while, it's definitely worth it. Now we can just hit play, and it will run. And if we set a breakpoint later on, we can pause the code and inspect the variables, which is super helpful. Okay, it's time to write some real code now. In our main folder, we're going to create a new folder called source, and this is where we're going to put all of our custom code. And we actually don't need that much. Colyseus does a lot of the heavy lifting for us, so we can focus on our game logic. It might be good to pause here and explain a little bit about how Colyseus actually works and the strategy it takes for running games. Basically, it maintains the state of the game and handles all the communication between players. And it's what's called an authoritative server, meaning it's in control. The people playing the game can ask it to do things, they can ask it to change the state of the game, but it's up to the server whether it decides to actually do it or not, and if it does make a change, it will reflect that change out to all the players. And that way everyone stays in sync, no one can cheat easily, and we know nothing's getting lost or translated wrong. So the first thing we need to do is consider what the state of our game looks like. What do we need to keep track of in order to run the game? We kept track of a lot of things in Unity, but the server is concerned with a few different things, and we need to decide which of those are going to be public information that should be synced to the clients and what's going to be private information and only the server should know. So let's create a new file and we'll call this state. By setting up the state of our game explicitly, the server knows exactly what it should store, how it should send it, and when changes are made, it can transmit just those changes. It doesn't have to send the whole thing every single time. So the first thing we need to know is who's in this game. So let's make a class for the player. And before we do that, we need a few things. We need to import the schema. This is what Colyseus calls the state classes, so they're all based off of this thing called schema. And we're also going to need a few more things. We need type, so we can say which data types each of the fields are. We need map schema, so we can store collections of objects that are like in a dictionary format, organized by key. And we need array schema, so we can keep track of lists. Okay, now we can make our player class. So we're going to export a class called player, and it's going to extend this base schema. The first thing we need to keep track of is what player number is each player. So we'll call that seat, and it will be a number. And we're going to annotate these fields using this type helper and tell it what data type this is. This isn't super important for this simple of a game, but if you only need to transmit a small number, there's no sense transmitting a big number. And similarly, if it doesn't even need to be a number at all, or maybe it just needs to be a single true or false value or a string of text, it's important that it know what data type this is so it can synchronize it between the players efficiently. So I think a 16-bit integer is totally fine for this. We could go smaller than that, obviously, but it's just for simplicity, I'm going to make them all the same. The other thing we need to know is the unique identifier for this player on the server. I mean, that's called the session ID. And it's a string. So we will annotate that with string. So there we go. Now we have a nice class for player. And now we can make our overall state. So there's sort of a top level object that keeps track of everything, and it will use the class we just created. So let's make another class. We'll call it just simply state. We'll also extend schema. And this is all related to our game. So first, we want the players, who we just referenced before. So we're going to say, well, I think we'll store those in a map, actually. This is going to be a good way. We can organize them by their session ID, so whenever something happens to a player, we can look them up easily because we'll know their session ID when they send us a message, and we'll also know their session ID if they join or leave. So let's make a map of players. This one's a bit trickier. So what you do is you say map schema and then the type that it's going to contain, which is the class above, player. And I'll just initialize it right now. And the annotation for this, you just kind of have to either look it up every time or figure it out. So it's going to be map colon player. There we go. Okay, what else do we need to keep track of? Well, we need to know the phase of the game. Let's just write these down. The phase, we need to know whose turn it is. We need to know who won, if anyone has won already. And we need to keep track of where each player has fired their shots. So for each of those, I think phase is pretty easy. We can use a string for that. And then let's create a variable for the player turn, a simple number, along with the winning player, also a number. And you know what, we'll just make that -1 to begin with, so it doesn't match any player at the moment. And we'll set the initial player to 1, so when the game starts, it's player 1's turn. And the initial phase, that will be waiting, because when the first player joins, they'll need to wait until another player joins before they can actually start. Okay, and then lastly, I'm going to make 2 separate arrays for the shots fired by each of the players. And this will keep track of whether it was a hit or a miss, and that way we can easily update the UI in the game. We'll just use a simple number here, and 0 will be empty, and then 1 is a hit and 2 is a miss. Okay, and we need one just like that for player 2. I suppose you could make a nested or a multi-dimensional array for this, but for a game this simple, I'm just going to make 2 different arrays. One for player 1 and one for player 2. All right, let's just clean this up a little bit. Let's go ahead and add in all of our annotations. We've got a few numbers here, so let's just paste in our number fields and our string field. And these array schemas, they're going to be a bit different. So they're going to be a type of array, and then inside the array, the type it is. So that'll be like a short. And it's the same for both of them. Okay, I think that's our schema sorted out. So we have who's in the game, what are we doing, whose turn is it, did anybody win yet, or who won, and where have people fired their shots. That should be enough to run the game. The last source file we need is the actual game room logic. We call it a game room. It's sort of an analogy for how you would play a game in real life. You know, 2 players enter the room, they play a game, and when they're finished they leave and the room is torn down. I guess they're quite disposable. So in our game room, we're going to set it some parameters for how many people can join, and we're going to assign the state object we just created as its method of keeping track of the game state. So let's create a new source file, and this can just be game room. We're only having one type. You can have multiple different kinds. You could have a chat room and a card game and a whole bunch of different things all running on the same server. For us, for this simple basic game, we're just going to have the one room. Okay, and we need a few imports here at the top to get us started. We need the base room from Colyseus, and we're going to need the 2 state objects we just created. Okay, and now we're going to make a new class, and this is going to be called game room, and it will extend the base room. And we're going to give it a little hint here. We're going to tell it that its state is of type state, which is the type that we created. And what that'll do is every time we reference the state inside this class, it will be strongly typed and it will be aware of all these fields, which will make our lives a lot easier, especially if your game was more complicated. Now we can start customizing this a bit. So first thing we want to do, there's a property called max clients that exists in the base class, and we want to set that to 2 since this is strictly a 2-player game. And then I'm going to define some other variables just to keep track of quantities of things. So again, our grid size, it's pretty much fixed at 8. We're just going to define it as a variable though, just in case we ever do want to change it. It would be a little bit easier. We also want to have kind of what the overall health of the fleet is. So as each ship gets attacked, and one of the spaces sort of blown up, then that's 1 health removed. And we know the size of all the ships, so let's say starting fleet health, this is also a number, and that will be the scout's health plus the cruiser plus the carrier. And again, if this were a more complicated game, we could create some kind of sophisticated way of recording those, and that would be calculated in a fancier way, but we're just going to hard code it for now. And now we're going to make a couple of arrays that are private. This information will not be shared with the players. We want to keep track of where both players' ships are. Obviously, each player should only know where their ships are. So we're not going to store, you'll notice in the state, we're not storing here, the ship placements, only the results of the shots. The hits or misses, that's sort of public information, if you will. But the ship placements, that's private. Only the server should know that. So we're keeping that out of the state, and we're just going to make a simple array here. In fact, let's make a two-dimensional array, and the first index will be for player 1, and the second index will be for player 2. So we'll call this placements. This will be an array of numbers. This will make more sense once we actually start using it. And similarly, let's make another array for player health. A couple more things I want to keep track of separately here. I want to know how many players have placed their ships, so we'll make something to keep track of that. And I'm going to keep track of the player count in its own variable. We could inspect the state and all that, but it's just going to be more straightforward if we just have it separately here. And it's not that much extra code. Okay, so the base room has a number of what are called life cycle events that occur as the room comes into existence. Players join, leave, messages are sent, etc. So we want to hook into each of those and kind of create our own logic for what should happen for each of those events. So the first one is on init. And since this is a very simple game, all we need to do here is maybe print out a message so we know it's working. And then we're just going to reset the game. But we don't have that logic yet, so we're just going to hold off. Okay. Next, we want to handle when someone joins the room. So there's one called onJoin for that. And we know when someone joins a bunch of information about their client being the representation of their game UI connecting to the server. So again, I'm going to put logging in each of these just so that when this is running, we have some insight to what's going on. So we'll just print out their session ID. Once the room is running, they're known by their session ID as they join the room. I think we can import client. Yeah, there we go. Okay, we also want to know when someone leaves. If you're in the middle of a game and someone quits on you, we're going to have to cancel the game. A couple more here. We want to know when a game client sends us a message. So again, first parameter is the client, and the second parameter is the actual message, which could really be anything. So again, we'll make another logging message here. Okay, lastly, when the room is torn down, when everyone leaves or the server shuts down, we have an onDispose, no parameters this time, and we're not going to do anything, we just want to know when it happens, so we'll just say room disposed. Okay, and then down here at the bottom, I'm going to write our reset function. This will restore the game to its initial state, ready for a new round. So starting with the player health, we need to make a new array of numbers. Again, array index 0 will be player 1, array index 1 will be player 2. So let's initialize them to their starting health. So if we say player health, let's be player 1 equals starting fleet health, let's just copy that, and we'll do the same thing for this. This is wrong. This should just be an array of numbers. So similarly, for the placements, we want to create a new multi-dimension array this time. So this will be an array of numbers. Make sure I get all my brackets right. To initialize this, we need to set player 1 and player 2's sort of slot here equal to a new array of numbers. So it's a bit easier. So it's pretty straightforward. Just going to say placements 0 equals new array of number. And then we'll duplicate that for player 2. Just like how we did for the game client in Unity, we're going to calculate the number of cells, and we're going to follow that up by creating a new state for this room. So We created this state class. We need to make a new instance of it and assign it to this room as the initial state. So let's create a variable called state. We'll mess with it a whole bunch, and then we'll assign it all in one shot when we're done. When it starts, we're going to say the phase is waiting, and the turn is 1. So player 1 will go first, and the winning player is not defined as a valid player. Then we're going to set up a loop here, and we're going to go through each of the possible cell indexes and initialize their starting values. So starting with the placements, they're all going to be blank for both players. And then in the state, remember, where people have fired their shots, that's public information, so that will be in the state, and we're going to initialize those as well. So the player 1 shots, those are going to start out as blank, which we're representing with 0, and same for player 2. Again, I could have used a multi-dimensional array for this. I'm not sure how well the schema would handle that, and it's easier to understand in this case. Okay, so now we can say set state and assign that as our initial state. We have one more thing to set. The number of players who have placed their ships is 0. That's important because we need to know this information to know when we can proceed to the next phase of play. Let's run it and make sure we haven't broken anything. Okay, not a really good test actually. Let's go ahead and register the room. So this is the other important piece we have to do. In order for the server to know what room types are available, we use the register command. So here I'm just going to say game server. Well, actually I need to import our room first. And now we can say game server register, and we'll give it a handle. So this will be just game. Again, we only have one type of game room, and then the constructor for that. Okay, we can start the server again. Nothing should have changed though. No one's joining the server, so no copies of that room are being created. And you know, if we wanted to, we could start setting up the client to connect and make sure we have some signs of life. But since this server is so simple, we're just going to finish writing all the logic, and then we'll switch over to integrating the game client in Unity into the server. So back to our game room. Let's make this smaller. Let's revisit each of these lifecycle events. In init, we can now call our reset function, and we can proceed to handle each of these other events. So when someone joins, what do we want to do? Well, we need to do a couple of things, at least. We need to increment our player count. We need to add them to the players map in the schema, and we need to see if we have enough players to start the game. So let's do each of those things in turn. So to start out, let's make a new instance of player, and we'll assign this player's session ID to the client's session ID that is now in the process of joining. And the seat they are sitting in is equal to the player count plus 1. We'll make this 1 indexed just so that when you say it out loud it makes more sense. Someone sitting in seat number 1 makes a bit more sense than someone sitting in seat 0. Okay, now we need to add them to the state. So if we access the state, and now since we strongly typed our room with our type for state, it's aware of all these properties, so we can access players directly. And we want to store this player referenced by their session ID. Again, because each of these events has this client being passed in, oops, a little typo there, we will always know this, so we can easily look them up again. There we go. Put them in their spot. This also comes in handy later, since we are syncing this to the game UI in Unity. This will let us know which player we are, so we can identify whether we are player 1 or player 2. Okay, let's quickly increment the count. And then let's check to see if we have enough players. If player count is equal to 2, then we'll change the state of play to place, which is the way we're going to indicate it's time to put your ships where they go. One last step, we're going to lock the room. This prevents other players from joining. And these rooms are going to be what are called fully disposable, meaning you can't reuse it. If someone leaves, it just ends the game. There's no someone taking their place or anything complicated like that. You can't wait for someone else to come along and finish what they were doing. So we never want people to be able to rejoin this game again once it starts. So we're going to just lock it up. If you wanted to, when someone leaves, you could unlock it, but we're not going to do that. Speaking of leaving, let's fill this out. So first thing we want to do is remove them from the state and decrement our count and put us back into waiting mode. Great. All right. So now moving on to message. This is where most of the fun is going to happen. So there's a few messages we can receive from the game client. If you think about what we were designing in part 1 in the UI, there's a couple important, well, yeah, there's only 2 messages that the client can send: where they placed their ships and where they're taking their turn. And that's pretty much it. So trying to keep this example simple, so we're going to go with that. So let's set up a switch where we can handle each of those cases. But how do we know what the command is? We have this message, which could be really anything. Well, we're going to agree on a little contract here with the game client, and that is that every message sent is going to have a parameter called command. And that way, we can identify what their intention is and send the code down different paths depending on what it is, because the rest of the message will probably be different depending on what type of command it is. So let's do some sanity checks here. We want to make sure that we know who's sending the message and if it's valid, and then figure out what the command type is. First off, is there a message? Let's just stop right away if that's not set, if it's not a non-null value. And then we want to know who sent it. So since we have everyone stored by their session ID, we should be able to look them up. And if it's someone we don't recognize, then we're going to just, again, bail out right away. There we go. Okay, lastly, let's figure out what the command is that they're sending. And if that isn't set for some reason, then it won't match any of the conditions in our case statements in our switch, so we're good there. You could reply back with an error or something, but again, keeping it super simple. So one message we can send is place, and the other message we can send is turn. That's it. And I guess it makes sense to tackle these in the order that the players would do them during the course of play. So let's make some logging statements so that when the game's running, we can tell what's going on. So we're just going to say, player, and then their seat number. And the way we're going to encode that is we're just going to go back to Unity here for a second. And if you remember, in our game controller, we have this list of placements, and it's just a big string of numbers, and it basically goes from 0, 1, 2, 3, blah, 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 all the way up to 64, because we have 8 by 8. And each spot has a 0 or a 1 or a 2 or a 3, depending on what kind of boat is sitting in that position. So if we just send that whole array over, the server will have everything it needs to know in order to check hits and misses. So we'll just count on the contract between the client and the game server is going to be that when you send the place command, that you are also sending along another parameter that is containing all the placement information. So what we can say is the placements, and then we want the player's seat -1. That will give us the right index in our multi-dimensional array here. It's going to be equal to the message key value for placement. Now again, this would be a place to add some more error checking if we were making a more robust real-world game, but for an example, this will do. And then we want to increment the number of players who have placed their pieces. Lastly, we want to check and see if everyone has finished placing. So if players placed is equal to 2, we'll change the state phase, and we'll call this battle, which will be the back and forth of people guessing where they want to attack. Okay, I think that's it for placing ships. Now at this point, the play would pass to player 1 to take their turn first, and they would come here in the game UI, and they'd select a cell they think one of their enemy's ships lies in wait, and they would click, and they would wait for an answer of whether it's a hit or a miss. Now in the board game, it's up to the other opponent's honor to tell you whether or not it really is a hit or a miss. In this case, the server is going to act as the referee, and it's going to check and tell both players what the result is. So the first thing we want to do is make sure that someone isn't taking their turn out of turn. We don't want player 2 to try to take a turn when it's player 1's turn. And this is going to be, a way to not allow cheating. Otherwise, you could just send like every cell in rapid fire and just carpet bomb them before they even have a chance to take a turn. So we're going to check to make sure that this state player turn, which again initially starts out as 1, if it's not equal to this player's seat, well, then we're done here. Next, we want to know where they intend to fire. What's their targeted cell? So let's assign a variable for target index, and this will be the message index named target index. So similar to how we had an agreement that whenever place command is sent, there'd be a placements key as well, we're going to have to rely on the client to also send this target index, which will be a number. Might as well put that as such. Whenever they send turn, they're going to also send where they're targeting. Okay, now for the trickiest bit. We want to find the array from the state that contains the shots for this player. Let's call that shots. And depending on what seat you're in, it will be one or the other. So we'll just say if the seat is 1, well, then it's going to be state player 1 shots. Otherwise, it's going to be player 2 shots. So now we have the right place set aside to record the result. And when we change this is the magic of Colyseus. When we change this variable, or any of the cells in this array, remember this is an array, when we change those differences are automatically sent to both players. So they'll automatically, later on when we integrate this into Unity, we'll be able to update where the markers are set in both the ocean fleet view and the radar view. Okay, so who are you targeting? If I'm player 1, then I'm targeting player 2. And then we need to know, well, okay, what array index are they in all of these lists up here? So to keep this easy to read and easy to understand, let's just assign a variable target player index. This is the person who's under fire. And that will be, if you, the player taking their turn, are player 1, then you're targeting array index 1. And if you're player 2, then you're targeting array index 0. Hopefully that makes sense. That should be a question mark. There we go. Okay, now what is the array we should be checking to find out if it's hit or a miss? Okay, that's going to be, we'll call that targeted placement. And that is the placements. And again, this is why we set this variable to keep our heads on straight here. So the index of the player we're targeting. So now we have the array containing the secret placement of the ships of the player that's currently being targeted. Now we're ready to do the check. Okay, so what's allowed here? Well, we don't want to record it as a hit and subtract from their health if they've already recorded a hit there. So we don't want to allow that. And if they missed, then we need to check for that as well. And there's one other case where they've either hit or missed, and they have already gone in that spot. But I think we'll just let players do that because, in the board game, you could make a silly move and target the same place twice, and your opponent would just say, well, yeah, it's what I said before, and then you would skip a turn, basically. So we'll just allow that in this case, but if you make your own game, you can decide how you want to handle that case. So let's check for a hit that hasn't been recorded yet. So that's not too difficult. We're going to use the targeted placements array. This is the enemy fleet, basically. And we want to know what's in the cell that lies at target index. This is the cell number that the current player chose. Okay, if that's greater than 0, we know it's not an empty spot. And if the shots they've taken at that same spot is equal to 0, we know they haven't gotten a result for that spot yet. So now we can say, we can fill it in, so to speak. We can say, okay, well, the answer of whether or not there is a ship there is 1. That's a hit. And now we can subtract some health away from that player. There we go. Okay, what about the miss case? If the targeted placement, target index, is going to start out the same here. If that is 0, and I'm just going to copy this, and we have not already recorded it, then we're going to do a similar thing, but we're going to report a miss. Now, in the next sort of cycle, as the game server runs, this change to the array will automatically get sent over to the game clients. So we'll see here at the end how that works, and it's kind of magical. Okay, so we can target players, we can check to see if it's a hit or a miss, and whether or not we should take some health away. The last thing we need to do is check to see when someone has won. And that's pretty straightforward now. We've set ourselves up for a pretty straightforward conclusion here. We just need to see if the person currently being targeted, if their health has gone below 0, or I guess if it is 0. I always just check if it's less as well, because why not? So if that's the case, then the person who just fired that fatal shot, they are now the winner. So we'll assign them to the state as the winning player. There we go. And we want to update the state of play so that the game UI changes. We'll change that to result. Otherwise, if they didn't win and there's still more ships to sink, then we just switch to the other player. So let's set the active player to the other player. So if player 1 is going right now, then it'll be player 2's turn. Otherwise, player 1's turn. Okay, we might have to debug that a little bit, but I think that's everything. We're handling the state, people coming and going, all of the commands that can be sent from the clients, and setting up the initial game. So I think we're ready to integrate. In the final segment of this video, we're going to go over the integration. So we've done all the work to set up our UI in part 1, and so far we've set up our server, and we think it's working pretty good, but we really don't have any way of testing it effectively. So we're going to add some classes here that are going to help us do this quicker. The first one is called generic singleton, and basically it lets you have something in Unity that you only have one of, and once you create it, it kind of sticks around between scenes. And that's going to be helpful to us because we want to have one connection to the server, and we want to go between the connecting screen and the game screen and not have an interruption there or have it thrown away. So we'll need that. And then I'm going to simply drag in a class that I wrote called GameClient. And this is basically a wrapper around the connection. And it's going to make interacting with the game server a bit more simple. We also need the code for the Colyseus client. So you can download that from the Colyseus website. So if you go to the Getting Started section for Unity, and this download link here gives you a zip file with a bunch of stuff in it. And what you want out of that is the plugins folder. And I'm just going to drag that into our project. There we go. And we need one more thing. So when we wrote our code in TypeScript for the server, we created this state representation. And there's a handy utility that comes with Colyseus that lets you export the client-side version of this automatically. And then you don't have to write it yourself. I'm going to go ahead and grab that as well. So again, if we go back to the documentation here and you look under the state handling, we're using schema, which is the newer version of state handling. And if we scroll down here to the bottom, so this is showing us how to generate this. We do npx and then schema code gen, followed by the name of our state. So I'm just going to park that, I don't know, over here so I can see it. Go back to Visual Studio, make this a bit smaller. Okay, so we're in our game folder, and we want to say npx schema code gen. And you would have to do this every time you make a change to your schema so they stay in sync with each other. Or if you really know what you're doing, you can manually change it, but That's up to you. So our schema lives in state. We want to output this as C#, and the output folder, oh, let's see. I want to go up 2 folders into the client folder, and then go into assets, scripts. There we go. And you can see it generated 2 separate class files, one for the overall state and one for the player object. And that's because we have 2 classes defined in here. Okay, that's enough from that and that. Here's our new classes we got automatically generated. And if we go over to Visual Studio, let's see what this created for us. Okay, so here's our state, and you can see the types it chose are based on the ones we selected when we were making the server. So an int16 became a short, a string became a string, and so forth. So game client. This is a lot to go through in one video, so this is one part I'm going to gloss over. But I am going to go through what this is for. This is using the generic singleton class I just imported. That allows us to have one of these between scenes. And I'm creating my own event handlers here for all the important events we care about. And we can attach these in Unity, and we'll see how to do that in a minute. One of the main things we care about is when the game state changes, so we've abstracted that into its own event handler, and that allows the 2 different scenes to know when the state's changing in a very succinct way. So then we have the actual client. This is the Colyseus client. This represents our connection to the server. We have the room. This is our connection to the room. And a variable to keep track of whether we've received the initial state or not. Okay, so a bunch of convenience accessors, some cleanup. When the game quits, we want to leave everything and close down everything. And now we get into the good part here. So when we connect, right now we're just going to connect on localhost because we're running the server here on the same machine. If you had the server running on Heroku or somewhere else, you'd want to change just to the IP address of that server and make sure that the right ports were open and so forth in your firewall. Then we're going to set up a new client based on that and attach the listeners to that. Then we have this bit that's required in order to get the listening cycle up and running. This is kind of more low-level networking. If we jump down and look where that's started, we're starting a coroutine where we connect, and then we're just going through a loop and constantly trying to receive information from the buffer. We don't really care about that. That's low level. We'll never look at it again. Okay, back up to here. So connect, that just gets us connected to the server, but we're still not in a game. To do that, we need to join. And since we only have one kind of game room on the server, we're just going to do join game. Remember, we gave this handle before when we wrote the server code, and that will get us into that room. Once it's connected and it's ready to start sending and receiving data, we call connect and hook up the rest of our event listeners. Next comes the leave command. This is where, if you quit the game, if we had a button that said, surrender or leave, it would call this and it would quit out of the room and null it out. Then we have send placement. So when we're placing ships, this is how we're going to send the message. So remember on the server, we're expecting a command and then the array of placements. So that's just what we have here. And when you take your turn, similarly, we have a command and we're calling that turn. And that is the index in the map that you're targeting. So those match up nicely to, in our game room, those match up nicely to this place and turn. Okay, then we have a bunch of handlers for when the connection's opened, when we've joined, and we're mostly just forwarding those on to code outside of this class. We're doing a little bit of simplification here for other code that we write where, if we have the state changing and it happens to be this particular field, then we're going to fire that as a separate event. All right, that's enough looking under the hood there. Let's close that all out. Let's go back quickly and pay some attention to our connecting scene. This doesn't have to be terribly complicated. We just need a really basic screen that just says, hey, we're waiting for someone else. And maybe we'll make the message on this screen conditional so that as the state changes, we can see what's going on. So here we go. We're going to just make a text field in the middle of the screen. Let's create a controller for this scene as well. Okay, there. And I'm going to bring in some code I already wrote for this as well, since this part's not very interesting. this class is pretty straightforward. So we have a reference to the message, a reference to our game client, and since it is that singleton class I was talking about, we can get a hold of it anywhere in code by just saying instance, which is nice. We're just going to attach to these listeners so we can update the UI when we're connecting and when we're joining. And once we've joined and we're waiting for someone else to join the game, we can show that message as well. Once the phase of the game changes to place, we want to change to the game scene and then throw away everything we've been doing on this scene. We'll go ahead and add an instance of the connecting scene controller to this object, and then we want to reference this text box for any event messages. I think we should be able to run this now. Let's start the server, and then we will try and join. Okay, server's running, and if we go back to Unity and we run this scene, there we go. So those flashed by pretty quick, but let's go back to the server window, and you can see that a room was created, and that's good, it didn't crash, at least not yet. And we know that presently this is our client ID. And so now if I go back to Unity and I stop the game, you can see that that person left and that the room was thrown away. So at least so far everything's going great. And we can just leave the server running like it would in real life, and we'll join it multiple times here as we build this out the rest of the way. Let's change our default text here. It's kind of sloppy. How about connecting? I think that's the connecting scene sorted out. Let's go back to the game scene. Now, when we initially developed this, it's essentially a single player game that you can't really even play. And we tested all the different components just by manually hard coding them into different states. So now it's time to actually hook them up to the state, sort of watch the state, if you will, and change things around accordingly. And the first thing we want to do when we get here is check to make sure we're actually connected to the server and joined into a room, or otherwise none of this will work. Let's go back to our class for the game scene controller. And right here at the top, the first thing we want to do is check to make sure that we're connected. So we're going to pull in a bunch of extra stuff here. First we need scene management added at the top here, and that way we can switch back to the connecting scene if we're not connected. Let's go ahead and add a reference to the game client class. We're also going to want to keep track of the state of the game, so we'll make a reference to that. And we need to know which player number we are in a couple of different areas, so let's add one more variable for that as well. We want to set our client equal to an instance of the client, and if the client's not connected, then we just want to go back to the connecting screen. And we can do that using Scene Manager. Next, we want to set up several event listeners for all of the important network events that can happen. We want to know when the state has changed, when we've received the initial state, and if the connection is closed. So let's define those handlers first, and then we'll hook them up. So let's just go down here to the bottom. These will be private, obviously. And we'll just make a new section that I'll just quickly label networking. Let's make one for the initial state. These are all normal C# event handlers. So this is an important event. When you receive the initial state, you're basically getting a snapshot of everything as it exists when you join the room. And then after that, you're just going to get updates pretty much of what's changing. We're going to grab a reference to that. We'll set our state equal to the initial state. And first thing we want to do is find out who we are. If we look at the state that we just got, we should be able to look at the players list that we created on the server and find ourselves by our session ID. So we have our client, and we know what our session ID is. So therefore, we can look up who we are. We're going to use that to set our player number. First, I'm going to check to make sure we actually did get one back. And if we did, then our player number is our seat that we're in. Otherwise, I'm going to set it to something, invalid. Okay, that's good enough for now. We're going to have to add some more stuff here to watch different parts of the state for changes, but we can't do that until we define them. So let's move on. The next thing we want to look for is the player turn. If we create a handler here that we can use to watch when the state changes, this function will be called every time something, any one of those fields on our state object changes, this will get called. So that's going to be really handy. So that lives in schema on change event args. we're going to loop through every single change. If the changed field is equal to player turn, then we're going to check to see if it's our turn. So let's define that function as well. For this, we're going to look at the state and see if the current player turn matches our player. So check turn, if the state player turn is equal to my player number, well then that means we can start our turn. So we already defined that earlier in the UI building phase, so we can just call that from there. And then otherwise, we're going to be waiting for our opponent turn, and we define that as well. Okay, now we can hook that up here, just call check turn. So every time we see that the player turn has changed, we're going to call this and look to see if it's us or if we should be waiting for our opponent. Okay, the other big thing we need to check for is phase changes. So as we go from waiting, placed, battle, result, we need to call each of the functions we defined earlier in the UI building phase respectively. So let's create another function for that. Okay, this one's going to be a switch, and we're just going to look at the phase. If we're waiting, we want to leave the game, because that means we had someone to play with, but now we don't anymore. So we'll have to do that in a minute. And then if it's placement time, well, then we can begin ship placement. And if it's battle mode, then we want to check whose turn it is. And if it changes to result, well, then we want to show who won. Okay, so we didn't have anything to put here for this one. We want to go back to the connecting scene if this happens, so let's just define that here. I think it might also be a good idea to just disconnect at this point, so we'll tell the client to leave the room. Let's go back to the top now, and we can hook up some of these event handlers we just defined. So let's take out this testing code. We are now calling that at the right time when the server tells us to. So instead, we're going to put in all these event handlers. So when we receive the initial state, we want to send that to our initial state handler. And when on game phase change, when that changes, we want to handle that in game phase change handler, naturally. There's one more little thing we need to do here, and that's if we get to this screen and we already have the initial state, well then we want to just kind of manually call our initial state handler. There's a bunch of other more sophisticated ways you could handle this, but they're outside the scope of this video. So we're just going to do it a sort of manual way there. Now if we have an actual state when we get here and this wakes up, we'll just call this ourselves, and then we'll be up and running. It's important to do a little bit of cleanup here too, and I usually add these as I go. So when this scene is thrown away in onDestroy, we're going to call and unhook all of these handlers. Okay, so I think we have enough to run this again, and we should be able to see the state change as a player joins. And we might mess around with the server a little bit so we don't have to actually have two players. So let's go back to our server, and we're just going to cheat here a little bit, and we're going to say, well, it's okay to place your ships when there's only one player. And that will prevent us from having to run two copies of the game, which is a little complicated at first. Let's go ahead and run that again with that change. Okay, and we'll go back to Unity. We should be in placement mode now, but we're not, so something's awry. Let's investigate. So here's the issue here. We defined this initial state handler, but after determining what player we are, we're not actually watching for anything here. So let's go ahead and just add an event listener for state on change, and it will be this function directly below. And we also want to do an initial check of what phase we're in. So let's manually call game phase change handler. The phase is going to be whatever the state says the phase is at the moment. There we go, placement mode, just as we expected. So we can go ahead and place these guys. and we actually get the waiting for opponent to place ships message, but that's just fake right now. We're not actually sending the ships to the server. If we look at the server, you know, it has this message that we joined, but it's not printing out that we sent our ships because we haven't put that in yet. So that we could do that next. So if we dive back in here, we need a way to send the ship placement to the server. If you recall from the game client, everything we send to the server we've put in this class. So right here we have send placement. We're going to call that from our controller. So right here, where we've determined that we've placed all the ships, we're going to say client send placement, and we're going to send it our placement array. See if we can receive that on the other end. There's going to be a lot of starting and stopping of the game. 1, 2, 3. Did we get it? We did. So we see placed, and an array of 64 elements was sent, and we see that one player has placed so far. Now the game state did not change to battle because we're still waiting for the other player, so actually everything's working the way we would expect. We're going to make one more adjustment to the server so we can continue testing with just one player relatively easily. So we allowed the game to proceed to the placement phase with only one player, and now we're going to allow the battle phase to start even though the other player hasn't placed their ships. The effect will be that there are no ships in your opponent's field and you cannot hurt them. But that's okay. We just want to make sure that state transitions appropriately and that we can send our turn to the server. So this will do for now. So we'll just allow the battle phase to start after only one player has placed their ships. Start the game again. Okay, so I should be able to place my ships, and now it's my turn. Look at that. Okay, it correctly changed to that phase of play, and I now have the cursor. And when I click, this is the next thing we need to do. We need to make sure that when I click here, I'm actually transmitting my turn to the server. So you know what to do. Go back to Visual Studio, and we're going to use the other sending command, send turn. In part one, we put a to-do here, and we're going to erase that and replace it with the real thing. So we can say client send turn, and the index that we're targeting. There we go. 1, 2, 3, and fire. Okay, so we took our turn. Nothing happened. It just went away, and now it's the opponent's turn. Well, we need to add one more set of eyes on that state. We need to watch for when the results are updated, both down here in the fleet view and up here in the radar view. So that will be the last thing we do, and then we'll be pretty much done. So we'll go ahead and put this near all the other networking stuff right here. And we want to have a handler for when the collection of shots, as we're calling them, for player 1 or player 2 changes. And then every time it changes, we'll just set a marker at that position, and we'll be good to go. So let's call this shots changed player 1. How about that? We'll end up with a little bit of duplicated code, but it'll keep things simple for now. Since this is an array of short integers, it's going to be shorts for the value and integers for the key. And the changes are sent one at a time, so we can handle each of them individually, not short. Okay, so which marker are we showing? Well, that depends on what value is sent. Remember, 1 is a hit, 2 is a miss. So we can set our marker equal to the change value. But we want to check if it's a 1. We want to set it to a hit, otherwise it's a miss. Now it's just a simple matter of telling the map view that we want to set a marker in that spot. See how nice it is when we set up a clean interface between each component? We can just tell it, hey, at this spot, show this thing. If my player number is 1, and it's player 1's shots that are changing, well then, in that case, I want it to show up in my radar screen, because I'm the one who took the turn. Now I have a small problem here, because we're talking in array indexes here, and this particular component is expecting a coordinate. So let's go over here and just improve our interface a little bit, and we'll make it accept either. Let's make another version of this function, and this one will take an index instead. to compute the coordinates, it's a bit trickier than going the other direction, but it's not too bad once you get the hang of it. So what we want is to convert that single number index in the list into a two-component coordinate. So we're going to create our variable named coordinate. We're going to use the modulus operator to calculate the x value, and then do some division to get the y value. So the x value is going to be the index mod size, and the y value is going to be the floor value of the index divided by the size. And as always, we're not using z, so it's just 0. There we go. Now we can just call the function we already have because we've done the conversion here, so we'll just say set marker. We just need another one of these for player 2, and in this case, we just need to check if it's player 2. And now we actually have to hook this up. So up here, when we got our initial state, initially we're listening to just this on change, just so we could know when the turn, which player's turn it is changing. But now we want to add some additional things here. So this is another area where Colyseus is doing some magic for us. We can say this player shots array, we can actually look for changes on it specifically. So when its contents change, we'll be able to find out. So we can add an onChange handler to that specific collection. And this is super handy for any kind of game, whether it's players on a map or coordinates of things changing or whatever it is. You can just easily listen for when it's changing. So we'll add this to shots changed player 1, and then we'll make a similar one for player 2. 2 and 2. We'll run it and see what we get. Okay, placement and fire. Still nothing. Okay, so now it's time to show a little bit of debugging. I'm fairly certain the client is set up correctly, but let's make sure everything's correct on the server and go from there. So I'll disconnect, and if we go back over to here, I mentioned earlier we did that work to hook up the debugger, and that's going to come invaluable right now because I want to see what's happening when this turn comes in. I know it's going to the next turn, so it must be hitting this, but I don't know what's happening in here necessarily. So let's put a breakpoint right here, and we'll rerun the game. Okay, so we get through placement. Now here's where it's breaking down. I send my turn, and I'll just send it at 0, 0, so we really know what we're going to get here. This should be index 0. Okay, so here's the message payload, and you can see it's index 64. That's a little strange. Okay, well, in any case, it should still give me some kind of a result, so let's keep going. And I'm player 1 right now, so I should be in seat 1. Okay, that's what I expected. Moving right along, I'm targeting player 2, right? And that will be the placements of player 2, which are all zeros right now. And that makes sense. They don't have any ships, and because we skipped over their ship placement so we could test easily. So that's still fine. So when we go over here, okay, so we know it wasn't going to come in here because it's not a hit. It should come in here as a miss. Target index 64, ooh, it did not. So our math must be wrong when we're sending this target index. Let's go back and look at the client, because 64 is actually out of bounds. It's a 64 length array, so that can't be right. All right, let's remove our breakpoint, and we'll go back to Unity. The first thing I'm going to check is our math for calculating the turn coordinate and converting that. So let's go to take turn. Okay, well this gets a coordinate, and y times map size plus x. That's pretty straightforward. I think that's correct. So then the thing calling this must be wrong. So if we go down a little further into map view, that's called here. And yep, I see the problem. So when we were doing our testing, we had compensated for the fact that the radar screen is above the regular fleet view, and we had offset this a bit. But now we're not doing that anymore. When we substituted in the actual call to take a turn, we accidentally deleted that. So let's go ahead and add it back. Okay, I think that's all that will be required. Let's start it again. Put our ships down and fire. Hey, there we go. Okay, so that's a miss, and that's what we want to see. Since the other player has not placed their ships, every single spot's going to be a miss, and now it's their turn and we're kind of stuck. But So far, everything's going great. So the last thing to do is to export a copy of the game so that we can play with 2 people at once, and then we'll really know if everything's working for sure or not. So I'm going to stop this, export the game, and we'll put the server back to normal so that both players have to place their ships, and we need 2 players to play. And we'll restart it. And then we're going to export this from Unity. So we'll say build. And I don't know what we're on right now, so let's switch to the web. And just quickly adjust some settings here. Resolution, I want this to be switched around 600 by 960 since our game is kind of a portrait style game. Maybe be better suited for a phone. Okay, so there's that. I think that's all we need to change. We'll switch to web. Okay, then we're going to make a build copy. I'll just save it to the desktop. And this will take several minutes. Okay, it's finally finished, and we have our exported project for the web. And you can't just open this index file because most browsers will complain that it can't run for security reasons. So I use web server for Chrome. So once you start this, you just choose a folder to be the root of your website. So it'll be this. And then you can just click on this to open it, and there you go. I forgot to add the connecting scene and the game scene, so we need to add this in here and then rebuild it, so I'll be right back. One other quick fix here, we want to change this to be the ship type. There we go, should be all squared away. We can place our ships in a creative formation, and then for player 2 we'll do the same, maybe less creative. Okay, so now we can attack. So for player 2, let's just go straight to cheating. That's it. There we go. The last thing we could do is change this message. So we want it to say who won, not just game over. So we'll go ahead and make that correction here. So right here, instead of saying game over, we want to look and see who won. Okay, that looks better. This one didn't change because we'd have to re-export the game, but I think that just about covers it. Hope you enjoyed it. Let me know what you think in the comments.